So hi everyone, this is Peter, my name is Adam, we're from Red Hat, and we are working on a project called Fedora Modularity. By the way, we have stickers for you, so if you come here after the talk, you can get one or two.
Only 25 of them.
Yeah, only 25, but that's fine. So I'm not sure who of you was on Langwei's talk last year here in FOSDEM. He was talking about how distributions are great, but not really, and how we might need to change them to be ready for the future. So let's start with why they are great, because I think that's still true. They ship packaged software, which means it's pretty easy to install. They also ship dependencies and everything else with it, so it just works. They integrate it and test it, so nothing breaks really. And some important thing, it's also patched for security vulnerabilities, because for example, if you are a developer and you're developing your application which is included in the distribution, you might not have pretty much time to patch for some security holes, so distributions can do it for you. And distros have a lifespan, which basically means they're released at some point, die at some point. This is for example Fedora, and if you have a look at a bit more detail, we can see that I have, for example, distribution version 1. It includes some libraries and software which is pretty much frozen for the whole lifetime. And then I have another distribution, another version, and the same story there. This is fine, but there are some problems, because for example applications are released at their own pace, independent of distributions, and they can also come in multiple versions, which means conflicts, right? Distributions often include only one version of every application because they got dependencies, they can conflict with each other, and it will be impossible to install. So we need to choose a version, but how to choose the right one? That's a tricky question. Because for example, if you are a developer, you might prefer this one, fast and latest, because that's what developers want. But if you're a sysadmin, for example, you're running an application, you don't want it to change so much, right? So you might prefer the other scenario. So I guess the right answer, we need all of them. We can't just choose one. But how to do it? Well, there are several solutions to this. So for example, we can have distribution on a fast track and another one which is a bit slower. So for example, this can be Fedora, this can be CentOS, or Ubuntu LTS. If I'm a bit more crazy, maybe I can have continuous upgrade. But this still doesn't allow me to mix and match versions as I want. So another solutions are software collections. How many of you heard about software collections? All right, so that's like half. So software collections are kind of special packages which install software in a separate space. So I can install like more versions of the software on the system. But it's pretty hacky. It doesn't work always. So that's a solution, but not ideal. Another thing would be Linux containers. Who of you know Linux containers? Almost everyone? That's great. So yeah, we know it's an isolated space which looks like a system, and it's for single application, and I can run multiple containers on system. But sometimes if I put stuff in the container, I need to look after for it. I might have problems with updates, and still I'm building containers out of a single distribution. So if I install some different version of something, this can get conflicted as well. So that's why we are working on modularity, which kind of combines everything together. And now I have like 1 minute short animation with subtitles, so I won't be talking. So if you could please read.
Or you can just read the subtitles.
No. This is a talk. I'm not supposed to be talking here. Alright, so that's basically it. So it will look like this. We will have something called base runtime, which is a tiny system with a pretty long life cycle, and another software. And the software will be like, how do you call it in English? Independent of the distribution, right? So, as I said, base runtime, this is what Peter's going to talk about, which is a small system containing software with proven API stability, like kernel and glibc, and some basic tools to make it boot. And the software will run as a module, and module is similar concept to Android applications or iPhone applications, so it's pretty independent of the system, and it includes all the dependencies in itself. And as I said, modules are like applications, so it can be database, it can be Firefox, but it can be also LAMP stack or basically any group of packages. And it will look like this. So I will have packages and some metadata, and I can also have packages as an API and as dependencies, which the difference is that if I, for example, have a Firefox module, the Firefox package will be API. This is the only package I care for, but I can have a lot of dependencies, libraries, etc., which are not guaranteed to be stable. But users won't care about this. Users care only about the API. And modules are defined as by Modularity file, and it basically defines everything, which I'll show you right now. So that's the Modularity. It's kind of cut off on the top, but there's nothing important. Important is that we have some name, stream version, which is an ID of the module, description, licensing, some references where the project lives, backtracking, some optional metadata, and here is the important part. So I have dependencies. There is the base runtime, and to build it there are build requires, which is base runtime and base runtime build. I guess Peter will tell you more about it. And these are lists of the components. So I can include packages in my module, and I can include another modules in my module, which might be useful. For example, if I have an application requiring Python, I don't have to list all the Python packages, I just list the Python module. And in the RPM world, if I have a source package, I can build multiple binary packages of it, but So in the RPM world, I have source RPM packages, which are packages containing the source code, and if I build it, I can build multiple binaries. And I don't want to probably include all the binaries. There can be devel packages and stuff, so I can filter them thanks to this filter. Here I can specify the RPM's API, and in the future there will be more types of API, not just RPMs. And also something called install profile, which is interesting. It basically explains how to install the module, and I can have more ways to installing. So for example, if I have web server, I can install it as a production or as a developer with different configuration. So that was Modularity, and Modularity is modules are built in something called Factory 2.0. I don't have time to talk about Factory 2.0, but if you can Google, for example, or find talk recordings from DEF CONF, which was like last week, you can find some interesting stuff about that. And yeah, and when we build them, modules are delivered as multiple artifacts, which can be RPM repo, Linux container, Flatpaks, OS3, ISO, whatever. And the distribution, when we put it back together, will look similar to this picture. So I have base runtime, the minimal system Peter will be talking about, and I have the modules running on the system. In this example, I have RPM packages here and container images here. And as we can see, as I say, the module contains packages and all the dependencies, right? So there are some challenges how to deal with, for example, conflicting packages in these two scenarios. So That's why we use technology similar to software collections to avoid that, or we can use containers. And what should I choose, RPMs or containers? Well, I don't really care because the workflow can be pretty similar. So for example, this is pretty bad. I will just make the window. Yeah, so in Fedora we use DNF to install software, so I can type DNF install HTTPD, which is a web server. I can configure it by editing the configuration file. I can add my index.html, and I can use system control start HTTPD. So that's the workflow in current Fedora. This can be the workflow in the modular Fedora. And I can't say if it's container or RPM packages. It will be pretty same for both. And maybe even a few days later I can DNF update. So the workflow will stay the same even with modules, which is, I guess, important. So how all of this works? So we focus on the package instead of on the distro version. So for example, in Fedora we store all the packages in dist-git, which is distribution git, and each package has several branches. So for example, F24, F25, which is like Fedora 24, Fedora 25, Fedora 26, and we want to change that to reflect the package. So for example, I can have package and have branches according to the versions. So instead of building distribution versions from the dist-git, so taking like all the branches F24 to build Fedora 25 and taking all the F25 branches to build Fedora 25, I can use modules to build modules. So I can, in the module MD, I can specify packages I want to include in a module, and I can just mix and match whatever I want, and then I can install it on base runtime. We call it module streams, and that's like variant of the module. We don't call it versions because in some cases it will be true, but if I have, for example, LAMP stack, I can't say what is version of LAMP stack because I have version of database, I have version of PHP, so that's why we call it streams. And these are basically just variants of the modules. And before you install, you will be able to choose the right version, or you can just download ISO with the versions pre-selected, so the user experience will be kind of same like with Fedora today. And you can use DNF. DNF update will work. It will keep your system up to date. So that's basically it about the modular distro, and now Peter will tell you something about the base runtime, which is the minimal system.
Yeah. You give me a microphone?
I can give you a microphone. There you go.
Okay, so how does it work? I guess I will just hold it. Okay, so as Adam mentioned, the base runtime is a module that sits below all the other modules, all the other stacks that we have. This part is named generational core though, so I will provide some background on what generational core is, what base runtime really is, and the difference between them. Base runtime was originally meant to be only the lower layer of this diagram. It was meant to provide hardware abstraction layer with system tools, utilities, and shared libraries to be provided by other modules included in a stack that we wanted to call the generational core. This initiative is temporarily on hold, however, because of the complexity and the introduction of modularity to Fedora. We don't have all the resources and the plans and the and the clear idea how to actually separate it, what components go into which module and so on. Also because the name is quite long and nobody could pronounce it, nobody really understood what generational meant in this context. we decided to just broaden the definition of base runtime itself, include some of the system tools and libraries, not the shared libraries layer. I will get to that. But basically, when we talk about the base in Fedora 26, we mean base runtime, not generational core. We may still revisit the idea of the generational core in the future. So, the implementation. Don't worry about the picture. It's not really important if you can't read it. Yeah, it's a module like any other. It's defined in a Modularity file. It lists all the components that we want to build as part of the base runtime module. It provides a stable and minimal bootable system on bare metal machines, on virtual machines. It also defines the container base image for both systemd spawn and Docker files, just Docker. The components that we include were inspired by the LSB core set, POSIX userland, and the atomic host. Currently, we include 700 binary RPMs defined by roughly 170 source RPMs. When installed as a container base image for Docker, it's 82 packages, and it takes roughly 88 megs of this space. How we actually implement it is that we have the module I just described, which is something we want to ship, but we also have to build it somehow. So we have another module called temporarily base runtime build environment, which includes all the build dependencies of the components in base runtime. It also includes all the build dependencies of those build dependencies and all the entire recursive build dependency chain. Currently, it's roughly 2,800 packages, which when built is roughly 6,000 binary RPMs. Although we will ship the base runtime build environment, we won't be supporting it in any way. And in the future, we hope that parts of the build environment will be split into the applications themselves, and base runtime will build depend only on itself and the applications that provide the components needed to build it. So. Okay. Yeah. I will try. Yeah, I know. I'm just quiet speaker. So the challenges that we face when developing base runtime is that there's more than one way to do it actually. So choosing the right content is the biggest challenge. We decided to go with the with the LSB core set and the atomic host set and the POSIX userland set I mentioned previously. But it's definitely not the final list. We may exclude some of those components or add something else to it. Keeping it as small as possible is important because we minimize both the memory, the space footprint, as well as the attack surface. And of course, smaller set means that we can rebuild it much more faster, and we can also test it faster. Another problem is building the whole set. We started with Fedora 25 beta, and just hoped that selected those 3,000 packages we needed for the base runtime and base runtime build environment, and hoped that they would magically rebuild themselves and it would just work. That didn't work as expected. We got like 400 failed to build from source issues in the first run. That was mostly because Perl was removed just before Fedora 25 beta was branched. Many packages build require Perl but don't explicitly state the build dependency, so they were failing, and it was mostly caused by AutoTools and AutoConf. So we fixed some of the issues and then rebased our sets to use Fedora 25 release candidate 3, which and the build dependency failures, the build failures dropped to 180 back then. So we created a new tracker bug, and we were reporting all the FTBS issues to the package maintainers. It was mostly the missing build dependencies, but it was also another more poor packaging practices, for example, and the lack of CI in Fedora wasn't helping. Another issue was the unresponsive maintainers. For example, when we reported those FS issues, we gave all the maintainers 2 weeks to respond, otherwise we would just fix it for them. In most cases, we had to wait the whole 2 weeks because there was no response whatsoever. In other cases, the package maintainer had a different opinion how to fix the issue, which is not always a problem, but it just slows down the progress. Of course, the discussion helps if it has potential. Another issue is that we are developing base runtime and all the modules in parallel with the traditional release. Since we are trying to build it, we haven't actually got past that yet. We are working with the frozen package set, and Fedora is still introducing new changes in rawhide. That includes GCC 7, package conf, basically anything. Also, when a maintainer fixes an issue, for example, with building the package, they often rebase the package, which means new dependencies and new build failures caused by the rebase. That's not always helpful. This is a picture with the build dependency graph of the current base runtime self-hosting prototype. It includes those 3,000 packages and the build dependencies between them. As you can see, when trying to minimize the build dependency chain, both for runtime or the self-hosting prototype, because it just takes forever to rebuild, and with all those issues, it's just a nightmare. Many of those dependencies are obsolete and could be removed because they were added like years ago and nobody really cares anymore. But finding them, that's the problem. I can provide SVG picture later. So what we plan to deliver in Fedora 26, the proof of concept based runtime module with the first version of the API. Hopefully all the packages in the API will also ship with the devel sub-packages so people can actually use our API. That's not as easy as it sounds because the devel sub-packages often will require stuff like Perl, and we don't want Perl in base runtime, of course. We will also ship the build environment module, although unsupported. We will ship we will ship system and container management modules such as DNF, which is not part of base runtime because it moves at a different pace. The same for Docker, for example. We will also ship like a proof of concept of the selection of the dynamic languages modules, mostly for Python. Again, the same situation as with Perl. We don't want Python in the base runtime, but many of our tools, including RPM build, unfortunately require it. In the long term, we would either ship like a small set of Python standard library, including like small Python interpreter similar to System Python we have now, but completely disconnected from the Python 3 Fedora ships today. We will also ship Project Boltron, which is a funny name for Fedora 2026 server, composed entirely out of modules. Unfortunately, Fedora 26 won't have any updates. The reason is that body cannot handle any artifacts besides RPMs. We are working on fixing that though. And it will be made entirely by the Modularity working group members. The reason is again that we have no infrastructure for end processes to process like for example, module submission requests and changes in the package database. For Fedora 27, we hope that base runtime will be much more stable. All the API will be usable. The packages that are not meant to be part of API will be repackaged and shipped differently, so that couldn't be accessed by anybody who is not meant to be using them. The same for the dynamic languages runtimes. We hope to finish the System Python and Python 3 split, for instance. We will support automated builds and rebuilds, so whenever you push the dискette, you will both build the component and the whole module and all the modules that depend on it. We will ship updates. The update for body is in plan. The modularity infrastructure will be open to public, so anybody will be able to submit a module and build it. There will be a new release of Fedora server and more content. It doesn't have a name, the new release. And beyond Fedora Cloud, Fedora Workstation, hopefully, that will include modules like GNOME, for example. Yeah, we hope that modular releases will become our primary deliverable, and the traditional release will be still available, but will be composed out of modules. So we will pre-select several modules for the users and flatten them out into a traditional release. And it will be awesome. Yeah, so that's the end. We have plenty of time for questions, if there are any.
So a question about the modules. So I think modules also encapsulate things like end-user programs, right? Command line utilities. How do you, for example, deal with shared libraries? Happen that, for example, an executable depends on OpenSSL. How do you, for example, ensure that a specific version of OpenSSL doesn't conflict with other packages? They may be conflicting, right?
Right. So yeah, the question was if I, for example, have an application that depends on a library. Yeah. So how do I make it not conflicting with other libraries, right? Yeah. So as I said, I can maybe switch back to my slides. So you can use containers. So the module can be installed as a container, and the container will have solved that already. Or if you want to install it as an RPM, we might need to repackage the libraries or the dependencies in a way that it will be installed in a separate path.
Okay, so each container basically has its own private copy, doesn't it?
Yes, yeah.
So there's no way to share these libraries?
No, not in containers. Containers are meant to contain everything in themselves. So.
Okay.
But just to further comment on that, right? So base runtime will have some libraries that are shared amongst other things.
Yeah, like it seems.
Yeah. Well, and at the beginning, it's probably going to be more stuff than we would like. So ultimately, we would like that shared set to be smaller, so that you can have independent versions. But at the beginning, it'll be likely fairly large.
Because I can imagine that if the entire system is built on those modules, it could be quite expensive in terms of disk space and also maybe RAM consumption. Because I think that Linux kernel caches the same files in RAM that can no longer be done.
Right. Yeah. Yeah. There need to be optimizations, but yeah, that's I guess more for the future. In the RPM world, yeah, if we have one library of a certain version, I think it will be just once on the system still. But yeah, in the containers, there's no choice basically. But we can still use layering. So for example, I can have the base runtime layer, there I can have some libraries layer, etc. And if they're the same for the same container, they will share both storage and runtime resources. Right.
If I understand correctly, the problem you're trying to solve is the problem of installing mutually incompatible versions of the same package concurrently.
That's not the only thing. Another is that, yeah. Another problem is that we want to offer applications, not packages, and we want them to offer them an upstream-driven life cycles, not the distribution-driven life cycles. So we will ship the RPM repository or container depending as upstream releases new versions, not as we just decide to.
And what about different versions, different instances of packages which are nominally the same version but have been built against different dependencies for whatever reason?
The question is about basically the same package and is basically the same version but built against different versions of dependencies. We will build all the variations against all the dependencies in the chain. So yeah, there will be a lot of artifacts available in the repositories, on the servers and mirrors, but the system management tools should choose correctly which module variant to install for you.
The problem is that sometimes there is no correct and incorrect.
Well, there is, because we track how we build it, so we know it.
Okay, so your users have to accept your opinion on which is correct.
So yeah, maybe I'll try to answer differently. Each module will contain all the dependencies, but also the build recipe. So it will be always built at the same time. So for example, it will reference particular version of the base runtime. It will reference, or basically if there are more versions of base runtime, it will be built against both, against all of them. But in a module, I can specify all the packages by branches, for example. But when I build them, the build system will save the exact commit hashes, so it will be reproducible at all times. And yeah, the module defines all the software it needs. Oh, you can say.
This concept still requires packages, right? In the sense that the applications are still being defined by somebody on the server side, whatever that means exactly, right? This isn't really meant to be exposed to end users per se, except that you may have multiple versions of something available to choose from. So, but that doesn't mean that it'll be that you can arbitrarily create your own modules locally. I mean, as a developer, you could, but that's not the concept here. The concept here is that these things are still all defined on the server side, much like RPMs are today, but the units of measure are quite a bit bigger for the most part, so that the individual things can have individual life cycles. That doesn't mean that you can't go in there and twiddle with the packages, but you're going to have a different kind of user experience.
Yeah. I mean, the reason why I'm asking those questions is because this very problem there's been a lot of interest in the last 2 or 3 years, and most people are tending towards the functional declarative approach that's used by systems such as Unix and DIGs. But you're still adhering to the imperative approach, so obviously you don't agree with the other people.
Or that's a big move. So that may be the long-term right answer, but that's a gut rewrite, and no way to distribute the existing distribution. So even if we were 100% sure that the Nix answer was the right answer, we can't just turn it off, right? So I think we're kind of walking towards that direction.
Yeah. Okay, so you consider this a kind of interim measure?
Well, maybe.
The road to supreme perfection.
Well, in the sense, like we won't know until we try it, right? So let's put it together. It's disruptive, but it's not train wrecking, right? And see how it works, and then and then iterate rather than make a big bet all at once.
Sure.
Any more questions? Yes?
For the containers, do you use Docker or system install for the server side? I know for the GUI it will be Flatpak, but for example, the web server.
Yeah. Okay, so question was, how do you run containers? Do we run them on Docker? Do we run them on systemd and spawn? And the answer is we will be using OCI containers, which will be able to run on Docker, run on RunC. And for example, if you have an OCI image, you can imagine, I heard a pretty nice example. For example, you can imagine PDF, which could be built by different tools, but you can open it in a browser, you can open it in a disk reader on your phone. So the OCI image will run on multiple container engines, but I'm not sure which would be the default.
We can do both.
We can do both, yeah.
Can you go to the factory 2.0 slide?
Yeah, but I have to find it.
Oh, it's too far.
Oh, there is it.
All right, so what's the carbon footprint of Factory 2.0?
Huge. Well, as you can see, it'll be a lot of building because, yeah, when building a module, we need to build all the packages. But I hope there will be some optimization, some nice filters to not have the carbon footprint as big as on this picture. Yeah.
I just wanted to comment some more on container runtimes. The container space is still a warfare zone. So if we were declarative about any particular tech there, we would be wrong in a week, right? So the objective here, I think, is that we want to do kind of the OCI model, which is the open standard, and then use different technologies to run them depending on scenario. Like, there's some of the reasons for the systemd container stuff is because you sometimes want to run a container before something like a Docker daemon comes up. So you need to, well, just like everything else, we have to be kind of flexible about the container runtimes that we want to use because we're going to need different ones for different kinds of containers.
Yeah, right. So do we have any more questions? All right, so I guess we can wrap up. Thanks for coming.